FoodDash now has two complete regions. Mumbai and Singapore each have multiple availability zones, application servers, a load balancer, and a database. Global routing can send users to either deployment. The regional failure problem is covered, but one decision remains. Should both regions serve customers now, or should Singapore wait until Mumbai fails? The boxes can look identical, while the system behaves completely differently. Welcome back to Engineering Systems. In the previous episode, FoodDash expanded from a multi-AZ deployment in Mumbai to a second deployment in Singapore. Now we must decide how both regions operate during normal conditions. This is the difference between active-passive and active-active multi-region architecture. These names describe traffic and responsibility, not whether machines are powered on. A passive region can still run servers, replicate data, and perform health checks. It is passive because it does not serve the main production workload. Let us begin with active-passive. Mumbai is active, so users are routed there and production rights are committed there. Singapore is passive. It keeps infrastructure ready and receives replicated data, but normal customer traffic does not depend on it. Singapore is a prepared replacement rather than a second serving destination. Global routing checks Mumbai while the standby verifies that its servers, database credentials, and dependencies are ready to take over. Then Mumbai fails. Global routing stops sending new requests there, but redirecting traffic is only one part of failover. Singapore may need to confirm replication has caught up, promote its database to accept writes, enable background workers, and start the jobs Mumbai previously owned. Only then should customer traffic move. If both regions accidentally run the same scheduler or consume the same work, failover can create duplicates instead of availability. Active-passive is simpler than active-active, but promotion still requires an ordered sequence. That sequence creates a recovery window. Detection takes time, promotion takes time, and clients may need to reconnect. A warm standby recovers quickly because most resources are already running. A smaller standby costs less, but may need to scale before accepting the full workload. A cold standby costs even less, but provisioning during an incident makes recovery slower and less predictable. Active-passive is a spectrum. Greater readiness means faster recovery and higher waiting cost. The main advantage is control. One region owns production rights, so there is one obvious source of truth. Database coordination is easier, background jobs have a clear owner, and engineers reason about one serving region at a time. The trade-off is that expensive capacity may spend most of its life waiting. Failover must be tested regularly because a standby can silently drift. An expired secret, a missing permission, or an untested dependency can turn a healthy dashboard into a failed promotion. Now change the routing policy without changing the regional boxes. In active-active architecture, Mumbai and Singapore both serve production traffic. Users near India can reach Mumbai, while users nearer Southeast Asia can reach Singapore. Health, geography, and latency influence the destination. Capacity is used during normal operation, and customers reach a nearby region. If Mumbai fails, its route becomes disabled and Singapore absorbs those users. Singapore is already serving real requests, so there is no passive stack to wake up. Failover becomes faster, but writes become harder. Imagine a customer creates an order through Mumbai. Then their next request reaches Singapore before replication delivers that order. Singapore may briefly believe it does not exist. Or both regions may update the same delivery state at nearly the same time. The system must decide whether one region owns that record, whether writes require cross-region coordination, or whether conflicting updates can be merged. Active-active traffic is easy to draw. Active-active data is the difficult part. Distance creates this problem. Synchronous coordination between faraway regions adds network latency to every critical write. Asynchronous replication keeps local writes fast, but the other region temporarily falls behind. Engineers often assign each user, restaurant, or order a home region. Both regions stay active, but each record has one write owner. Other systems use a globally distributed database or application-level conflict resolution. The correct pattern depends on the business rule. A profile description can merge more safely than a payment or order state transition. Active-active also needs capacity headroom. Suppose Mumbai and Singapore each run at 70% utilization. Together they look healthy, but after one region fails, the survivor cannot absorb the missing load. The remaining region needs spare capacity or a deliberate degradation plan, pause non-essential jobs, limit expensive features, protect checkout, and reserve resources for critical requests. A system is not region resilient merely because traffic is split. Failover capacity is part of the architecture, not an auto-scaling detail to discover during an outage. So the comparison is not modern versus old. Active-passive gives FoodDash one serving owner, simpler write semantics, and a controlled recovery process. It can cost less when the standby is smaller, but failover is slower, and unused capacity must stay genuinely ready. Active-active gives lower global latency, uses both deployments, and redirects traffic quickly. In exchange, it needs more capacity, stronger operations, and a deliberate strategy for ownership, replication delay, and conflicts. FoodDash does not need one model for every subsystem. Restaurant search, menus, and read-heavy catalog data can be active-active. Critical order writes and payment state can begin with one active owner and a passive recovery region. This hybrid is practical because workloads have different correctness requirements. The goal is not the most impressive diagram. It is the simplest operating model that meets latency, recovery, and data guarantees. For now, FoodDash chooses active-passive for the critical ordering path. Mumbai owns production rights, Singapore stays warm and continuously replicated, and automated failover exercises prove promotion works. As the platform grows, selected reads can become active-active, followed by writes whose ownership rules are understood. Multi-region does not require the most complex operating model on day one. But once both regions hold changing data, another problem becomes impossible to ignore. How does information move from Mumbai to Singapore? What happens when replication is delayed, a region is disconnected, or both sides accept updates that disagree? In the next episode, we will follow data across regions and explore replication, consistency, and conflict resolution. Thank you for watching Engineering Systems. If this series is helping you build a clearer mental model of distributed systems, consider subscribing. And, as always, keep learning.